Okay, welcome to my video section for chapter section 9.3 on separable equations. And I'll be going over a couple of practice problems, how to do separable equations, and tips and reminders on which equations are separable and those that are not. Our first problem for this video is finding just what y equals and without any general solutions to what y having x value and a y value. So the first problem that we have is y squared plus x y squared times y prime equals 1. The first step that we always want to do in a separable equations problem is to separate our variables. That's the first key into it, and it's kind of in the name, so that gives it off. So first we can factor out a y squared for the y prime. So we get y squared y prime 1 plus x equals 1. Then we can divide 1 plus x to the 1. So we have separated equation. The next step of this problem is to convert our y prime into d of y over d of x and substitute it in for the y prime. And you'll see why we want to do that. Y squared dy equals 1 over 1 plus x. Next, we want to put each variable with its own dy, dx, or any other variable. And a very important fact about this is that these always need to be on the numerator. Without it on the numerator, you can't take the integral of your equations, which is the main point of this concept. You always want to have these on the numerator, whether it be du, dx, dy, always on the numerator, or otherwise it would be not separable, and you would need a matrix for that. So now I'm going to take the integral of these two separate equations, or these two separate sides of an equation. So I'm going to erase my work to show you what antiderivative of y to the third over 3, and don't forget your constants with them. And then we have ln 1 plus x plus c. Now, most often cases you won't see the d within here because if you subtract the d from the left to the right, your constant will still be, your c would still be a constant with no variables. So most often cases you don't have to write the d and just can keep it as a c, which will make your arithmetic much easier with one less constant. Now we just want to solve for y. So we can have y to the third equals 3 ln 1 plus x plus 3c, and then we just cube it. There we go. That's how you separate equation. Take the integral of the two separate sides of the equation and you get your y. A second step to this to these separable equations is be giving a value for the y and x. So for example, if y to the 0 equals 1, we would have to find what the constant of c equals, plug it into this equation to finally find out what y really equals without any unknown variables. Now I'm going to show you an example of that problem next. The next problem that I have included is x plus 2y square root x squared plus 1 times y prime equals 0. But we have a general solution now as y to 0 equals 1. This is our x value, and this is our end y value. But first we want to separate equations and take the integral of them. So what we can do is subtract an x and divide by square root x squared plus 1. So we get negative x over square root x plus 1. Then we want to substitute dy over dx for y prime. Then, next step, take the integral of both of these. So we get y squared just for this one because there's a 2 right here, and that can go outside, which that becomes y squared over 2, simple. And then for this, we get negative square root x squared plus 1 plus c. And remember, as I said before, you don't have to write the d here because that's a constant and c is a constant, so it will still stay a constant. Now, the next step in this problem is to this is not the solution to our answer as in the previous constant. We want to plug in these x and y values to find what actually c is to get the true value of what y is. So, I'm going to erase my work once again and show you how to find c. So, we had y squared equals negative square root x squared plus 1 plus c. Now, our x value was 0 and our y value is 1. So we have 1 to the power of 2 equals negative square root 1 plus c. Now, the square root of 1 is 1, and that becomes negative. And the square root 1 to the power of 2 is 1. So we get negative 1 plus c. And c equals 2. Now, we want to plug it in back to our original equation, which is this. So, our final answer will be y squared equals negative x squared plus 1 plus 2. That's it. The main problem with these separable equations that you have trouble with is that if an equation is non-separable, and I'm showing you an example of how to confirm whether it is a separable equation or a non-separable equation. So I'm going to erase my work. The final problem that I will be doing is 5x minus y prime equals 7y minus x plus 2. So first step, always what you want to do is separate your variables to separate sides. So let's take the y to the left and the x's to the right. So we get negative 7y minus y prime equals negative 5x minus x plus 2. If you've noticed it by now, you would have noticed something different, as the 7y is not multiplying by the y prime, and it's actually subtracting from each other. So if we try to separate the dy and the dx, you're going to find some difficulty in doing so. As you try to move the dx to this side of the equation, you'll find that the 7y will now have the dx. And as I said before, you cannot have any dx or any variable on the denominator, and your equation is non-separable. Because as you try to take the integral, you can't, because there's a dx with a y variable. So this becomes a non-separable equation. To solve an equation like this, a matrix is used, or a grid as you want to call it, and you would plug in points for your x and y to find what the slope is for y prime, and you would draw cuts or edges or the slopes, and then given if the problem is a sketchy solution, you would draw a solution to that graph. That is separable equations, just separating and integrating your separated equations, finding what c is, and plugging what c is into it. One key thing to look out for when you're doing so as such is that when your equations include such things as multiple signs, changes in sign, which screws up many people. So for example, you have y squared. This is after integrating, and you get x plus c. One of the problems is that when you take the square root of this can become y equals plus or minus square root x plus c. And your general solution is, for example, 0 equals 1. So we have y equals plus or minus square root c. Now the problem is you have to find which value, you have to know which value of which sign to keep in order to make this true. So what value, c will always stay the same, but you want to make sure you use the right sign. So 1 equals plus square root 1. 1 equals 1. That's correct. But if you use the negative, you get 1 equals negative 1. Make sure to watch out for your signs when doing the separable equations, as that's where most problems occur. Thank you for watching my video.